So this is Block 1 General Physics, topic 1.2, motion. In this topic, we will discuss the motion or the movement of an object and explain the motion of an object in terms of distance, speed, velocity, and acceleration. These are the terms we will use to explain the motion. These are the learning objectives for this topic. Like you should be able to calculate and define speed, differentiate between speed and velocity, acceleration, and different types of acceleration and speed time graph, distance time graph. So this is a learning objective which after completing the discussion, the explanation, you will be able to answer these questions related to these objectives. So first thing, the quantity or a physical quantity. So when we have a physical quantity means a quantity which we can measure. So a physical quantity can be a scalar quantity or it can be a vector quantity. A physical quantity, a quantity which we can measure, that we call a physical quantity, and we divide the physical quantities into two parts. We say some of the physical quantities, some of the measurable quantities are scalar and some of the physical quantities are vector. But what is the difference between scalar and vector? A scalar quantity, a quantity in which we represent the magnitude. Magnitude means number and unit only, but no direction. So we represent the magnitude, we represent the unit, but without any direction, we call that as a scalar quantity. So example, if I say today's temperature is 39 degrees centigrade. So when I am saying today's temperature is 39 degrees centigrade, what this 39 number is representing, this 39 means the magnitude value. And the degree centigrade or Celsius, that is a unit. But we don't specify a direction, we don't mention a direction. Like when you're saying, stating a temperature, you don't say temperature in north, temperature south, east, west, upward, downward. So you don't specify any direction. So in this example, there is no direction involved. So whenever a physical quantity is represented without any direction, only magnitude and unit, that type of physical quantity is known as a scalar quantity. Is it clear, the concept of a scalar quantity? A physical quantity means a quantity which we can measure, that we call a physical quantity. But if a quantity is not represented by direction, it is having number only and it is having unit only, but no direction, we call that as a scalar quantity. Same thing, like if I say an object took 30 seconds to reach from point A to point B. So if an object took 30 seconds to move from one position to another, so what this 30 is representing, this 30 is a number and it is representing a magnitude. And what this second is representing, this second is representing a unit. But again you can see there is no direction. You don't mention like 30 seconds in east, west, north, south, upward, downward, right, left. So you don't specify a direction. So whenever a physical quantity is represented by magnitude and unit without a direction, that is simply called a scalar quantity. But what about the vector quantity? A vector quantity, it is represented by a magnitude, unit, and direction. So you represent a quantity by all the three parameters, which are magnitude, unit, and direction. You call that as a vector quantity. So example, if I say a force of 30 Newton is applied in the direction of east. So what this 30 is representing? This 30 is a number that is a magnitude. What is a Newton? Newton is a unit of force. And what about east? East is representing a direction. So you are representing by a magnitude, unit and direction. So when all the three parameters are there, what we call this quantity, we call that quantity as a vector quantity. Is it clear the difference between a scalar and a vector quantity? So a physical quantity can be scalar, can be a vector. Now some examples, and I want everyone to participate and sort out the quantities as scalar and vector. This is not the new chapter, this is topic, because according to syllabus it's a topic. Topic 1.2, which is about the motion. Normally in the book you find this as a describing motion, this chapter name. But this is topic 1.2. So sort out quantities as scalar and vector. Now I want everyone to use screen annotation. Screen annotation, you can see an icon like a pen or a pencil. You can use that to annotate on the screen and I can see your answer on my screen. So if I say speed is 30 meter per second, if the quantity is a scalar quantity, write S. If a quantity is a vector quantity, write V in front of that. So use a screen annotation. I want everyone to use screen annotation and state whether the quantity shown is a scalar quantity or a vector quantity. Speed, scalar or vector. Time, 13 minutes. Force, 45 Newton west. Yeah, below you can write as a scalar or vector. What about others? Distance is 5 meters towards only 5 meters. Use the screen annotation, Abdullah Sarfraz. Use the screen annotation. The reason why I want you to use the screen annotation, because I will give more activities related to this. You can see the option, there's an icon on the screen, there's an icon for a pen or a pencil. You click on that and you can annotate on the screen. Yeah, on the computer also you can use this option on your computer. You can use a mouse. The screen annotation, I enable screen annotation so every one of you can use that screen annotation. Check the option. So if we have a mass which is 4 kg, weight is 400 Newton, and weight is always, even for weight, we normally do not mention direction, but weight is always acting downward. And density is equals to 3 kilogram per meter cube. So simply a quantity, because there is a magnitude, you can see there is a magnitude, there is a unit, but there is no direction, so it's scalar. That is right. This one time, there is a magnitude and unit, but no direction, scalar. That's right. Force, magnitude, unit, and direction, vector. That's right. Magnitude and unit, it's a scalar. That's right. Magnitude, unit, and direction. That's right. Magnitude, unit, and direction. That's also right. That's a vector. Magnitude and unit, scalar. That's correct. Magnitude, unit, direction. That's vector, right. Magnitude and unit, that is scalar. So So a quantity simply represented by a magnitude and unit, we call that as a scalar. And a quantity which is represented by a magnitude, unit, as well as direction, we call that as a vector quantity. So thank you everyone for their participation. And I want others, those who did not participate yet, they should be able to use the screen annotation as well and state the answer. So when we are describing a motion, a movement of an object, how we can describe a motion or a movement of an object? We can describe a motion or movement of an object in terms of speed, velocity, and acceleration. These are the ways, these are the terms normally we use for describing a motion. So what about speed? The definition of a speed? Speed is distance changes over a time. So how much distance change over a time, using that we can work out the speed. So example, you have an object at position A and it moved to new position B and it covered 60 meters in 4 seconds. So what is the definition of a speed, or what is the meaning of speed? Simple meaning of a speed is a distance traveled in a unit time. In 1 second or 1 hour. So how much distance an object travel in 1 second, or how much distance an object travel in 1 hour, that is simply refers to speed. So what is the speed of this object? It covers 60 meters in 4 seconds. But what about the speed? So speed is distance travel in a unit time. So distance is equals to 60 and the time is 4. So 60 divided by 4, what will be the answer? That will be 15 meter per second. So what it states, 15 meter per second, it shows that this object, every second this object will cover 15 meters in 1 second. So distance travel in a unit time is refers to speed. And to learn the formula of speed, you can learn from this triangle. How you can learn from this triangle? Example, if I want speed, so if I need speed, then speed will be equal to distance divided by time. But if I need distance, so I will hide the distance. If I need a distance, so distance will be equal to speed multiplied by time. And if I need a time interval, if you want to measure a time, so time is equals to distance divided by speed. So using this triangle, you can work out the formula which relate the distance, speed and time. When object is moving, it might have a constant speed, speed might decrease, speed might increase. So speed of an object can be constant, it can be variable. Variable means changing. And the term constant and also the term uniform is used for a constant speed. So example of a constant speed, like object is moving from one place to another, one point to another. So object is at point A, then at point B, then point C, and then to point D. From point A to B, from B to C, and from C to D, it covers 5 meters. So here it covers 5 meters from A to B, 5 meters from B to C, and 5 meters from C to D. And the time it took, here it took 2 seconds. From B to C also 2 seconds, and from C to D it also takes 2 seconds. So when we find the speed from A to B, so speed is equals to distance travel in a unit time. The distance from A to B, the distance travel from A to B is 5, and the time it took to travel from A to B, that is 2. So 5 divided by 2, that is equals to 2.5, and the distance is in meter and time is in seconds, so it will be meter per second. What about speed from B to C? So from B to C, it covered again 5 meters, and it took 2 seconds to cover that. So 5 divided by 2, that's equal to 2.5 meter per second. And from C to D, so from moving from C to D, the distance travel again it is 5, and the time it took, that's 2, so 2.5 meter per second. So you can clearly see that this object, the speed is not changing. When the speed is not changing, what we call that as a constant or a uniform speed. So when the speed does not change, we call that this object is moving with a uniform speed. But what about a variable or a changing speed? A variable or a changing speed might have two options. It might be increasing, speed is increasing, and the speed might decrease. What is the example of speed is increasing? So an object moving from A to B, then from B to C, and then C to D. So these are the position A, B, C, and D. The distance A and B is different from B to C, and B to C is different from C to D. Say it cover 4 meters, then it cover 6 meters, then it covered 10 meters. Here it took 2 seconds, 2 seconds, and 2 seconds. So when we find the speed from A to B, so what is the distance travel from A to B? That's 4, and divided by time, it's 2, 4 divided by 2. So from A to B, the speed is 2 meter per second. From B to C, moving from B to C, it covers 6 meters, and it took again 2 seconds. So 6 divided by 2, that is equals to 3 meter per second. And from C to D, object covered 10 meters, and it took 2 seconds. So 10 divided by 2, that's equal to 5 meter per second. So when the value of the speed is increasing, we call that object speed is increasing, or it is a variable or a changing speed. And the last example, object speed might decrease. So what is the meaning of speed decreasing? The object is moving, but the speed of the object is decreasing. So we have position A, B, C, and D. Example, this was 6 meters. This is say 3 meters, and this one is only 1 meter. And the time interval is 2 seconds here, 2 seconds, 2 seconds. So when we find the speed of an object from A to B, so it is 6 divided by 2. So 6 divided by 2, that's equal to 3 meter per second. From B to C, it covered 3 meters and took 2 seconds. That is equals to 1.5 meter per second. And from C to D, it covered 1 meter and took 2 seconds. So 1 divided by 2 equal to 0.5 meter per second. So here the speed is increasing, speed is decreasing, and the speed is constant. Is it clear? The concept of the speed of an object, it can be a constant or a uniform. When speed does not change, we call that as a constant. An object will cover equal distance in a unit time. When speed of an object is changing, it might increase in speed or it might decrease in speed. Is it clear to everyone, the concept of speed and changing speed? Yeah, constant does not means stop. Constant means that the speed is not changing its value. So example, I will repeat. Look, an object is there at position A. It moved from position A to position B. So it moved from position A to position B. It covered 5 meter in 2 seconds. So speed is distance travel in a unit time. So distance is 5 and time is 2. So 5 divided by 2, that's equal to 2.5. But when I check from C to D, it also covers 5 meters in 2 seconds. So 5 divided by 2, again 2.5. So when you check the two values of the speed, there it is same, it is not changing. So we use the term that the object is moving with a constant speed or a uniform speed. If object speed is changing, we call variable or changing speed, and changing speed can be increasing or it can be decreasing. Example, object cover 4 meters in 2 seconds, so 4 divided by 2, that's equal to 2 meter per second. When you check the last interval, it covered 10 meter in 2 seconds, so 10 divided by 2, that's equal to 5 meter per second. The term constant or uniform is the same thing. You can say when the speed is not changing, you can say the object is moving with a constant speed or object is moving with a uniform speed. These are the same terms used for explaining the idea that the speed is not changing. Yes, Saim Ahmed, they are both same. There is no difference between them. And if an object covers 6 meter in 2 seconds, so 6 divided by 2, that's equal to 3 meter per second. Then it covers 1 meter in 2 seconds, so 1 divided by 2, that's equal to 0.5 meter per second. So you can see here that the speed of the object, initially it was 3, then it is 0.5. So speed is decreasing. So speed of an object can be constant, can be variable. Constant uniform is one thing, variable or changing is another thing. And speed is a scalar quantity. Scalar quantity means whenever we represent a speed, we represent by a magnitude, we represent by a unit, but we do not use any direction. So if I say an object is moving 30 meter per second, so what we call that as a speed. Why it's a speed? Because there is a magnitude and there is a unit, but speed does not have any direction. For a velocity, what is the meaning of a velocity? Velocity is displacement over time. So example, what is the difference between distance and displacement? Look, object cover 2 meters towards object. This is a starting point. Say A is a starting point, B is the ending point. So object move from position A to position B and it covered 2 meters. So what is the distance traveled by the object? Distance is equals to 2 meters. But what about displacement? Displacement is a vector quantity. It is having a direction. So example, if I say an object is at position A, it moved to position B and it moved towards right hand side. So what is the displacement here? So displacement of an object is 2 meter. But in which direction? So it is towards right hand side. So displacement is represented by a direction. Distance is not represented by a direction. So in displacement, we do not use any direction. We just use the number and the unit. So distance is a scalar quantity where displacement is a vector quantity. Example, another example, if an object covered 2 meters towards right hand side and then return back to the same starting point, what is the distance traveled by the object here? So what is the distance traveled by the object? Object first move 2 meter and then return 2 meter. So it will be 2 plus 2. The distance traveled will be equal to 4 meters. But for a vector quantities, the direction is important. If the same question was there, what is the displacement? in this example, so object start from point A, move 2 meters and then return back to the same starting point 2 meter. And the question is, what is the displacement? So how you will work out the displacement? Displacement is a vector quantity, and for vector quantities, we have to consider the direction as well. If one of the direction is positive, the other direction should be considered as negative. So example, if the right hand side direction I consider as a positive, then the left hand direction should be considered as negative, because right and left are opposite. So when the object is moving 2 meter towards right, I will say +2. But when it moves to 2 meters towards left, then I will say -2. Why? Because the direction change, when the direction of the vector quantity changes, we use or represent that by a different sign. So what is the displacement of this object? So it first moved 2 meter towards right, and then it moved -2 meter. So +2 and -2, so displacement is equals to 0. It means that the object returned back to the same starting point. Is it clear? The concept of a vector quantity and how we get the result for a vector quantity. Because for vector quantities, the directions are important. So if one of the direction, it's up to you, any one of them you consider as positive, either left or right you consider as positive, then the opposite one will be negative. But for distance, because it is a scalar quantity, so we don't have to consider the direction. So the direction is not included in a scalar quantity, but it is important for a vector quantities. Same way, if an object cover 5 meter towards right and then return back 2 meters, and you want to find the distance, what will be the distance traveled by this object? Yes, what is the distance traveled by the object? Move 5 meter, the distance traveled, not the displacement, distance. For a distance, we don't have to bother about the direction, we simply, distance is a scalar quantity, we don't have to consider a direction. So it first move 5 meter, then move 2 meter. So distance will be 5 plus 2, that is equals to 7 meter. Because distance is a scalar quantity, direction is not important. But the same question was there, object move 5 meters and then cover 2 meter. So 5 meters towards right and 2 meters. So it's up to you which direction you want to consider as positive. Example, right I consider as positive. So left will be negative. So what about the displacement? So moving towards the right we consider as positive, and moving towards left we consider as negative. So what will be the displacement? That will be plus 5 and -2. So plus 5 -2, that's equal to plus 3 meter. So plus means positive direction is towards right. So you have to mention the direction as well. So the final answer should be plus 3 meters. And what should be the direction? That direction is right. How I know the direction displacement is towards right? Because my final answer is positive. Because if positive is there, it means right, and negative is there, it will be left. Is it clear, this example, to everyone? I'll give another example, but before that, is it clear, this one? Another example, an object covered 3 meters. So an object covered 3 meters and then it covers 7 meters. The question is, what is the distance traveled by the object? In this example, the distance first moved 3 meter and then 7 meter. So the distance is 10. That's right. And we don't have to mention a direction. But what about the same question for displacement? First it covered 3 meters, then it covered 7 meters. So if right hand side I consider as positive, then left will be negative. So this will be plus 3 and this will be minus 7. So what is the answer for plus 3 minus 7? The displacement, that is plus 3 minus 7, that is equals to minus 4 meter. And what negative sign represent if my final answer is negative? Because the negative answer means left according to our first direction. So it is minus 4 meter towards left hand side. Is it clear the difference between the distance and the displacement? And what is velocity? Basically, velocity is displacement divided by time. And what is speed? Speed is distance divided by time. And velocity is a vector quantity because it is having a direction, where what is speed? Speed is a scalar quantity. It does not have any direction. And when object is moving in a straight line, if object move in a straight line, in that case the distance and displacements are same. If object does not change direction, distance will be equal to displacement when object move in a straight line without changing direction. So if there is no change in direction, in that case the distance and displacement will be same. Like if I say object move 2 meters towards right, so distance is 2 meter and displacement is also 2 meter because there is no change in direction. I'll continue the discussion as less than a minute left. I'll share another link with you.